Hello, my little mathletes. So welcome back to yet another fun and enjoyable day of e-learning from my basement. Okay, so what we are going to be looking at today is solving exponential equations requiring logs. Now, you guys just spent a few days solving logarithmic equations. And prior to that, we did solve exponential equations, but the exponential equations that we solved before didn't require logs. So right now, what would be a good idea is if you guys paused this and tried to figure out how to solve this. Now, pause it. Seriously, pause it. Do the problem. Is it paused? Are you doing the problem? You're stuck? Okay. If you're stuck, remember, you can take each of our bases right now and you can look at them and say, what can I rewrite all of those bases as? Do it. Pause it. Do it. Are you doing it? What number can they all be rewritten as a power of? If you said 4, you are wrong. If you said 8, you're wrong. What we want to do is we're going to rewrite all of these as a power of 2. Now this guy's already been done for us. So let's start over here. So I'm simply going to take this 8 and rewrite it as a power of 2. So 8 is equivalent to 2/3. So I have, not 2/3, that's a fraction, this is a power. 2 to the third to the x minus 1 times 2 to the x plus 6. Don't need to make any changes, it was already 2. And then 2 to the 5th raised to the 2x. So now all of them have the same base. Well, I need to apply my properties of exponents. And when I'm applying my properties of exponents, I know I'm going to distribute there. So I get 2 to the 3x minus 3. That was the little monster. And 2 to the x plus 6. There she goes. And then 2 to the 10x. So in order for me to solve this, I need to get so that I only have one base on the left side and one base on the right side. Well, I already have the one base on the right side. So now I have to condense this somehow. Well, when I'm multiplying, I add my exponents together. So this leaves me with 2 to the 4x plus 3 equals 2 to the 10x. So once I have a single base on the left and a single base on the right, now I can go ahead and I can drop my bases and solve the remaining equation. And so I end up with a solution of x equals 1/2. Okay. Now, the next problem, though, I want to kind of take a little bit of a closer look at. So in our previous one, we were able to rewrite everything as a power of 2. But when we're looking here, well, I already have a 2 here. But can I rewrite 5 as a power of 2? Well, no, because we know that 2 squared gives us 4 and 2 cubed gives us 8. So that's not going to be a helpful technique. But what this does tell us is that our answer is going to be somewhere between 2 and 3. And because 5 is closer to 4, we know it's going to be closer to 2 than it's going to be to 3. So that allows us to do some helpful approximations. But This is the reason that we have logarithms, is so we can get a precise solution to this. Now, there's two methods that we can use to do this. I'm going to show you both. It's really up to you guys as to which ones you want to use. Now, the first thing you're always going to need to do is to get that base and the exponent isolated. If that's not been isolated, in this case it is, you need to do that. But what I have to do now is I have to change this to logarithmic form. Well, if you guys recall, the base of your exponent is the base of your log. And remember, a logarithm is an exponent, so it's going to equal the exponent. So we end up with log base 2 of 5 equals x. That's the solution. This is the exact solution. Now, we've talked about everyone take out those calculators. Everyone take out your calculators. I've got mine. I've got mine, Mrs. Dempsey. Dude, give me back my calculator. What do you mean you think this is your calculator? It's my giant pink calculator that my dad got me, remember? I'll give you back your calculator if you give me back my iPad. I don't have your iPad. He has it. I'll give you back your iPad so you can get the calculator back to who that belongs to if you give me back my shoes. Okay, everybody. I'm going to turn around. I'm going to close my eyes, and I want everybody to give back whatever doesn't belong to them, and then we can continue.
Mom?
Oh, now she's here. So, when we go to do this problem...
No way!
Oh, no. Oh, that's me? You're going to be me? Do your teacher voice. No?
You.
Me? What's my teacher voice sound like? I'm trying to do a video right now, so you need to...
Mom, I want you to open the text.
Oh, okay. All right. I'm back again. So, remember, in order for us to do this in our calculators, we want to get to log base in our calculator. So you hit your math button. Most of you, the easiest thing to do is going to be arrow up to A, hit enter. So we get log base 2 of 5. And so we end up with x is approximately, that's a congruent symbol. What am I doing? X is approximately 2.322. So we said it was going to be between 2 and 3, and it was going to be closer to 2 than 3. Hey, we're right. Okay, now, method number 2. Now, if you have a log base button, this is the best way to do it. But if you're dealing with a calculator that does not have that, and right now there's a lot of free online calculators from TI and a bunch of other people, so all of you should be able, if you have internet, to be able to find a calculator. Now, the other method that we can use, if I have 2 to the x equals 5, and this is the method that I learned to use on. So what we're going to do is we're still isolating the base in our exponent, is I can take the log of both sides, and then I can take the x and apply that property of log and move it up. So we get x log of 2. There's a monster lurking. Ah! Stop. That was really loud for my scream, sorry. All right, and then I can divide by log of 2. And then this is another exact answer that is the same thing as this. This is the change of base formula. So, these are both exact solutions. If you wrote either one, you would be correct. Now, when we get to this problem, well, let's take a look at what we're going to do. Now, if I'm going to switch this to logarithmic form, well, first of all, if my base is 20, but I'm going to a number smaller than that, that's going to tell you that you're going to be between 0 and 1. Now, if I just rewrite this in logarithmic form, I get log base 20 of 10 equals x. So, where is it? Can you see it? And we get 0.769. Now, this is exact, and this approximate. But this whole concept is the reason that we have logarithms. Now, I also could have taken the log of both sides. So I get the log of 20 to the x equals log of 10. And then I can take this and I get log of 10 over log of 20, which is the change of base of this one. Okay, now they're going to get a little more complicated, but the good news is not too much. And this actually might be the last one I'm going to do for today. So when we take a look at this, we have more things happening inside of the exponent, and we have more things happening outside of the base. So in this problem, the first thing that I need to do is I need to get my base and my exponent alone. So I need to solve for this first. So I'm going to go ahead and subtract my 4. Then I'm going to divide both sides by 2. And so I have 1/3 to the 2x minus 1 equals 25. So now that I've isolated my base and exponent, well, now I can do what I was doing before. I can change this to logarithmic form. And so when I go to change this to logarithmic form, I have log base 1/3 of 25 equals 2x minus 1. Well, we can still solve this. We can still get an exact answer. Add my 1. Now, I'm going to put my 1 in front because I don't want to think I'm taking the log base 1/3 of 26. So I'm going to have 1 plus log base 1/3 of 25 equals 2x. And so now I can go ahead and I can divide both sides by 2. And so this is my exact answer. But in order for us to put this into the calculator, you're either going to have to put this in parentheses when you do it, or I'm going to enter it like a little bit different than it's written. So, see, you might have thought the first growl came from my dog, but that was my daughter. Now it's the dog. All right, log base 1/3 of 25. I'm going to end my parentheses. Plus 1. Hit enter, and then divide by 2. So my answer, this is my exact one, my approximate answer is negative 0.965. So there you have it, a good introduction to like one of the reasons that we have logarithms. This is how we solve exponential equations that we can't rewrite the base. So I will post this and some practice problems for you. I miss you all and have a good one.